So we're proceeding to the next lecture. Looks like we're about on track with last semester. We're going to build ourselves a WPF application. So what is WPF? Windows Presentation Foundation. Visual Studio comes with an editor for WPF. And the way the editor works is you can create a graphical user interface. You can drag text fields and buttons and create scrolling text areas and a sort. So we have some instructions for that. That'll be in the folder B. Let me unhide it and everybody will be able to see it. If you refresh your Dropbox, folder B, you'll see it now. Okay. So we need to launch Visual Studio. We're going to create a new C# project, but instead of being a command line interface, we're going to choose WPF application. And the point of this is to just get us started creating GUI applications as soon as possible. Because by the time you're in this class, you're already familiar with the idea of programming, using variables and things like that. So I'm not going to lecture through all the PowerPoints. I want you to go ahead and read them and, of course, read the textbook. So I'm going to do New Project, C#, WPF. And we could also do the same thing with Windows Forms. It's got the same editor works for it. Generates different code. So then we're going to find the Toolbox vertical tab on the far right. This should be the first vertical tab under Toolbars on the top. Hope it's there for y'all using Visual Studio 2017 with the light. Toolbox. So where it says main window.xaml, this is our editing. It's our window that we're going to be creating, our template. The toolbox is a list of controls that we can drag out there. And if you look down here, in this little window down here, not that I have much room on my screen to scroll up and down, it's actually creating an XML document, which you can even edit with a text editor. You don't have to go through this editor here. However, if you change it in the text editor, hopefully it'll change it in the editor up here. I don't know if you'll ever get to a point where changes that you make down here will not be reflected here. That can be the case in the in the NetBeans Designer. Let's go ahead and take a look at the toolbox. Common WPF controls, borders, buttons, checkboxes, and everything you drop on here can be controlled through the source code that you write. It generates source code for you, but your source code can also, it can hide controls, it can move them around, it can change the appearance, it can load new pictures into a picture inside of an image block. So we've expanded WPF controls. You got that right? Okay. We're going to choose button and we're going to drag it out there. Then we're going to double click it. That will launch the code editor. And I did not mean to launch PowerPoint. Stop that. Alright, I need a button and I'm going to drag it out to my little window here. Teeny tiny little thing on my screen.
What do you do when the toolbox is done? Like that whole side disappears?
Oh, well, just a sec. So if your toolbox disappears on you, you can get it back by choosing View, Toolbox. I wonder if I can pin it so that it's not popping up on top of the other one. I'm going to click the little pin icon. Now my toolbox. I'm going to squeeze Solution Explorer way over here. I don't need that much. If you hit Control and spin the wheel up, it zooms in your designer. This field is called the designer. If you lose that window, you can bring it back by choosing View Designer. Okay, so I've dragged a button out there. Double click the button. That'll bring us to the source code editor. This creates a method. The method that will be invoked when the button is clicked. And what do you know? It's got a real creative name. Button click. Now what we ought to do is to rename the button so that it has a better name. And then when we had created its method, it would have a better name. We can also rename that right there by choosing Refactor, Rename. I don't believe that was part of the assignment, so I'm not going to complete that, but I'll just leave that there. Alright, so if we were creating a console application, we would keep doing like this, but we're not gonna. We're gonna go down to here. So we want to create a little application, well, some code. We're going to add this to our method. It's just going to do a little bit of math. The important thing is that after it does the math, it uses string.format to create a string. And then we will display the string. We will use messagebox.show to display the string if we're using a GUI, if we're using WPF. Otherwise, we would use console.writeLine. I'm going to come back over here, and gosh, that's a bunch of stuff to type. I could just copy and paste it. I'm going to cheat and do that. Copy all that stuff and paste it. And if you open a PDF version of the file, copying and pasting is not always successful. However, I think all that we have there is an RTF or a doc. Alrighty, I already see some errors. These should be double quotes around hello rather than single quotes. And these should be single quotes around the C rather than double quotes. I don't recall if that was my intention or not. Yes, that was. Note that there are errors in the code. Fix the errors. Well, the errors are that strings are declared. String literals are declared with double quotes. And characters are declared with single quotes. That's just like Java and C and C++, but it's unlike Python where the two are interchangeable. So I'm going to change the literal hello to double quotes around it. And I'm going to change the character to have single quotes around it. And this is a mistake as well. C++ would not declare this as a mistake. Even though this is a float, it would feel free to go ahead and assign it into an int without even casting. Now we could cast this if we wanted to, but the easier thing to do would be to just change that 1.0. What does casting mean? Casting means to put the data type in front of the literal inside parentheses. And if we had that, then we would not have had to change our data like that. So this floating point number, even though it looks like an integer, it's not really an integer because it's got a decimal point in it. So it's stored in a completely different format inside the computer. But this takes that data, turns it into an int. And like I said, the easier fix would just be to remove the .0. But maybe this data was coming from somewhere else. Maybe it was coming from a function call. Yeah, something the user entered, something that had a decimal in it. Alrighty, well let's take a look at what this is doing. I hope by this point in your career you know what percent means. That means modulus. The way you think of it is 6 divided by 4 is 1 with a remainder of 2. If you don't know what modulus means, hit the textbook. Alrighty. In this one, we have to remember the rules of precedence. Order of operations. Order of operations say that multiplication and division happen before addition and subtraction. And modulus is considered a form of multiplication and division for that purposes. So multiplication, division, modulus happen before addition and subtraction. So we got to do that first. 2 times 5 is 10. Add 3 to that, that's 13. And here, this multiplication is the first thing to do. Order of operations. 3 times 2 is 6, plus 5 is 11. We hope this stuff's the case. When we run the application, we'll be able to compare our expected results with what actually happens. I'm going to build it just to make sure I don't have any errors in it so far. So build, rebuild solution. Rebuild all succeeded. Alrighty. Now I know what the next thing is going to be, which is to uncomment out the message box.show, but I'm going to go back to my instructions. So we've done 15. We've eyeballed them by hand. Now we're going to uncomment out one of the 2 lines of the int. If we were creating a console app, we would want to do console write line, but we're doing messagebox.show instead. What's a message box? It's a little dialogue. Little teeny tiny dialogue. You've seen it a billion times in your experience. I'm going to hit start, and it runs, brings up my application. It's not going to do our code yet until I click the button, and the button calls our method and does what we were supposed to do. I is equal to 2, j is equal to 13, k is equal to 11. And I believe that that's what this says, 2, 13, 11. Now I think I accidentally closed my app. Here it is. But when I call button and it displays it, I swear it looks like, do I have a breakpoint going on? Why is the, yeah, I accidentally set a breakpoint. You probably don't have a breakpoint there, but if you have a red dot over here in the margin, that's a breakpoint. Breakpoint means that when I run it in debug mode, which is what I'm doing when I click the green button, that it stops the debugger at that point. Now that was not my intention, so I'm going to delete the breakpoint. Now I'm going to click continue, and it brings back my GUI application again. Because clicking buttons should not close the app, right? Only clicking the close button should. X. And each time we press it, it invokes that function again. Now behind the scenes, a whole bunch of stuff is happening for that method to be called. Somehow, the second to the last time I ran it, it left some garbage on the screen. Part of this OK button was left. I don't know why that was. Anyways, this application behind the scenes has what's known as event handler. And the event handler is waiting, it's listening for clicks. And the Windows operating system itself, which is actually executing this app, waits for events to happen. What are events? Moving the application, minimizing it, maximizing it, changing its size, closing it. And when one of those things happen, like the X or whatever, then Windows, the operating system, sends that event to our application, and the event handler inside of our application calls that method. If we want to dig into it a little bit more, we can probably find where button click is being called. I'm not so sure about that. Go to definition of button click. No, that didn't find it. Well, I'm not going to dig too much into looking for the event handler of C#. That could be something that we could Google and take a little bit of time looking for. So, in class we may go over debugging options, but this is enough to turn in. Well, let's go ahead and debug. What I'm going to do, and I think we did this last time, maybe not, is I'm going to set a breakpoint for that line of code. And I've lost my line numbers. I'm going to re-enable them. Tools, options, text editor, general, all languages. Where are they? I hate doing this. Why is it take so long to find where the fonts are defined? Alrighty, it's under environment, fonts, colors. Every time I spin the scroll wheel while holding the control key down, it does increase the size of the text, so I don't need to do that. What was I trying to do? Oh yeah, line numbers. And that's not doing it.
Yeah, the very top. You scroll all the way, no, display items. See your bar, your display item window? Yeah, go all the way up. And then it's right, it's the fifth one down. So there's plenty.
Ah, right there, right there, right there. All right, line numbers. Well, that's to change the appearance of it. That's not to enable. Tools, options, text editor node. All right, I was there to begin with. It's my first place I went. I apologize for the waste of your time, because you've already done this. Text editor, general, or all languages. Please show me my line numbers. Thank you very much. Okay. All right, I like seeing this. So, your line numbers won't match exactly mine, most likely. In an application this simple, perhaps they did. It's giving us a little note here that the variable C is assigned, but its value is never used. Why didn't we get that for S? We assigned something to S, but later on we used string.format to stick some data into S. So we effectively rewrote this. We didn't even need that line, it gets replaced. So I click on the margin here, I create a breakpoint, and then I'm going to click Start, or I could choose Debug, Start Debugging, and it stops here. And now we have our little symbols up here, which I'm absolutely sure, I'm pretty sure that we did this last time. Did we do this last time?
Yeah, we did the breakpoint.
Alrighty, alright, so I'm not going to spend too much time on that. So I'm not going to use step into. Maybe I'll use step into when we get to string format. I'm going to use step over, step over, step over, and I can see the values change here. I should be able to find my variables, except they're hidden down here. My local variables, J, K, S, and C, they're all tucked away there. My autos, I'm not sure why S is not listed as an auto. I have created it, but C and I are there. We could go over there and find locals, and we would also see S as well, which currently has the contents of flow. So I'm going to keep clicking step over. Now I get to string format. I'm going to do step into, just because I want to see whatever code Microsoft included that does the string.format. So this one is step into, and it didn't do it. It didn't show us the source code for that. That's all right. We could write our own method, and then it would have jumped into it. So, dot format. I believe we talked about this, but we have these placeholders. These placeholders match the variables being passed in, and you can even change their order if you want to. You could say that that was supposed to be a 1, that was supposed to be a 2, and that would be a 0. And if this is 1, it would fill that in with a value of j. And if this is 2, it would fill that in with a value of k. Slightly different than what C++ uses. Excuse me, I'm not going to even say that. If you use string.format in Java, it uses a different style of placeholder where you use a %sign. And I do not believe that you have the ability of specifying which parameter fits into which placeholder. Alright, that's about enough of that. So let's hit debug, stop debugging. And was that the entirety of the lecture? It was, so let's go hit the PowerPoint for chapter 2. Also, I want to see what our homework is going to be. Actually, I'd rather play with the editor a little bit more. All right, so using data, declaring variables, displaying the variables, the integer data types, floating point data types, and arithmetic operators. I am really fairly certain that by this time y'all know how to do this. But if you got here without taking a C or a Java-based class, then this may be slightly unfamiliar to you, which is that in these strictly typed languages, you have to declare your variables before you can use them. Meaning that not only, I can't just do this out of the bat without having declared the variable first. So that's what this line does. And when you declare the variable, you give it a type, you give it a name, and you can initialize it with a value here as well. I could have said C is equal to, followed by this character literal right on the, without separating them. This one is cool, except console input. I don't think we did that last time. So a constant is something that cannot be changed after a program is compiled. Once the program is running, its value cannot be changed. In the source code, once it is declared and assigned a value, it cannot be changed in your source code, or else you will get a syntax error. So for example, if I declare string s, Bondi, as a const, remove my breakpoint. This is okay, because, whoops, no it's not. Some languages let you separate the declaration of the constant and the first time you assign it, not this one. So it wanted us to assign a value right here. So if we did this, great. But now we're going to get a syntax error whenever we try to reassign it. This is what's known as a named constant. An unnamed constant are these, what I keep calling literals. These code values that are literally typed into the program, right? Absolute only way to change them is to go open the source code and type something in. So you have numeric literals, you have character literals, you have string literals. Of course, this is not a constant, so I'm going to remove that. So our intrinsic types. These are the built-in data types, and they are aliases for a class in the system namespace. All of the built-in types except object and stream are called simple types. My brain they're called primitives in Java, primitive data types, except even in this language, absolutely everything is a class. In Java, the primitive data types are not classes. So if we look it up, there's a whole bunch of types, an absurd number of types. And if you've never done C programming before, it'll look way like overkill. You probably are familiar with the idea of the number of bits. The number of bits is what determines the size of the data that the variable can hold. And so, for example, a byte is 8 bits, because there's 8 bits in a byte. And so the largest value it can hold is a 255. Now this says that a byte is an unsigned value, meaning that it can go from 0 to 255. Unsigned means that negative values are not possible. A signed value is one that can go negative. The price you pay is that it can only go half as large as the largest value there, but on the other hand, it can go negative. So that signed byte can go from negative 128 to 127. Are you going to use a byte to perform math? Well, I probably wouldn't. It's not really to your advantage to try to maximize. If you say, okay, this number never gets larger than 20 or something like that, this is a person's age, so I'm only going to store it in a byte. There's no real reason to do that. It doesn't make your code run that much faster. And in the environments that C# runs, it doesn't we're not constrained by memory usage. So similarly, an unsigned short is 16 bits, which can hold values up to 65,000. And if there is a signed short, which I'm not seeing here, but if there is one, it would go from negative 32,000 to positive 32. And then integers. Integers can hold up values to about 2 billion if they're signed. If they're unsigned, they can go from 0 to 4 billion. Then there's another type, longs, or in C++, in Visual Studio, unlike other versions of C++, for the Linux operating system or Mac. We call them longs, which is an absurd term. But anyways, there's 64-bit data types that can hold far larger values. You know, a 9 followed by 18 zeros. And you can have signed versions of them and unsigned versions. Then you have your floating point numbers. These are the ones with the decimal points. One thing that this is not really showing is that the number of bits declared not only determine the maximum value of it, but the precision of it. This has 4 bytes in which to store both the mantissa and the exponent. The largest exponent that this floating point type, called a float, can store is 38. So if we try to store a floating point number with an exponent larger than 38, this is not correct, because this is supposed to be the smallest value it can store. The smallest value would be either negative 3.4, or it would be 3.4 times 10 to the negative 38, right? It depends on your definition of smallest, right? As close to 0 as possible, or the largest negative number. Anyways, so if it's using float, you have about 14 digits of precision. 3.44, whatever. If you're using a double, it can contain a lot more digits of precision. And maybe it's only 8 for a float and 16 for a double. So floats and doubles, the math should not be considered exact. You can get rounding errors using them, because the conversion from a decimal floating point number to a binary floating point is not precise, unlike integer math. So when you're doing floating point math, you may wind up with floating point errors. They're usually incredibly small, but you may wind up with them. If we Googled it up, floating point error example C#, we would probably get an example of one. Then there's a type called decimal, a fixed precision number. I've kind of forgotten what you use that for. It's even wider, right? So it can hold far more precise numbers. Notice that the exponent, the maximum exponent, is much smaller, meaning that the digits of precision would be much larger. So that would be an extraordinarily accurate. Hopefully you know what precision means. You know, the number of digits in the decimal points, you know, on the other side of it. Physics and chemistry term. You can also have chars. In C and C++, a char is most likely a single byte, meaning it's going to be an ASCII value, but in this language it's a Unicode, meaning it's a 2-byte value, and that way we can store German and Russian and Swahili and Korean characters in a char as well. Then you have Boolean, which is just true or false. You have strings, which is a Unicode string of characters. And then you have an object, which is any object. And all of these data types are actually objects, meaning that any piece of data we have should have methods attached to it. Let's see if that statement is true. For example, if I come up here and I do C dot, here we go. Got a whole bunch of different options. The one that we will most likely use is toString or compare to. Now, if it's just a character, you can use equals signs to compare, like, right, if C equal X. If you're using a more complex data type, you may need to call compare to. So anyways, we can convert that to a string if we wanted to. So down here, if we wanted to do messagebox.show, if we just wanted to display the contents of I, and we thought that messagebox.show only would accept strings, then we could do I.toString, parentheses in parentheses. So a method is a function that's attached to an object. So I is actually an object. It's not just a simple primitive variable, unlike Java. And this would convert the contents of that integer to a string to be passed to the message box. So when I run it, it should just print 11 or 2 or whatever I wound up being. Yeah, I was 2. Does MessageBox require a string? Can I print out I without this stuff? I believe the answer is no. In fact, it's giving me an error right here. So messagebox.show requires a string to work. And quite commonly, text entry fields and display fields on a form have to be strings. So when you get your data from the form, it's going to be a string. You're going to have to convert it to a numeric value in order to do math on it, if that's your goal. And then in order to update the display of it, or to, just have some kind of field that you're going to display, then you have to change it back to a string in order to have it display. I.toString is an ideal way of doing that. What have I done wrong? Is it lowercase toString? No? Alright. Maybe I just hadn't recompiled it, make the error go away. So declaring a variable, you give it a data type, a name. You can give it an initial value. If you're making it a const, you must give it an initial value. You can create more than one variable of the same type by separating them with commas. That's a common syntax in Java and in the C languages. We did that here. We created 3 variables. Now you have a problem here. You can't really just say 0 and have it assign all 3 values the value of 0. That only assigns k equals 0. If you want to assign them all after that, then you can use that syntax. I is equal to j is equal to k, and then give it a value there. And the associativity of it indicates that this happens first, and then the value of that gets copied into there, and then the value of that gets copied into there. So format string, a string of characters that optionally contains fixed text. We used a format string. We used a format string in our application here to generate our string to pass to messagebox.show. And it says optionally contains fixed text. Doesn't have to. There's a format string with no real fixed text, right? That would just put the value of I into the string and display it, which would actually give us the same output that we had when we called I.toString. It'll display it too. Just trust me on that. But of course we can add additional text there as well, like these numbers, or this number is, and it will display that as well. This number is 2. The placeholder consists of a pair of curly braces. Inside the curly braces, you can put more information than just which parameter to the format is being passed to it. You can specify how many characters wide, and you can specify how many decimal places, whether it was left or right justified, that kind of stuff. So here, the money is $0 exactly. When we ran it, it would print out, the money is 39.45. Now, if it was just 39 right there, or 39.4, it would not display the cents correctly. It would not have 2 numbers after the decimal point, which is what we like to see. If we follow the parameter number with a comma and then another number, that indicates the number of spaces dedicated to that variable. So 0, 5 means format this input but pad it out with 5 spaces, which is what we see there. And 5 spaces there also, it's still 5 spaces. Still 5 spaces. If we wanted to be left justified rather than right justified, then we would put minus signs in front of it. -5 would stick that 4 over there, and it would be followed by 4 spaces. A minus sign there would left justify the 5, 6, so it would be 5, 6 followed by 3 spaces. And this would be 7, 8, 9 followed by 2 spaces. And here they're printing out some names, so we have 2 parameters, 0 and 1. And all of the names are specified to be 8 characters wide and to be left justified. Now what if this is more than 8 characters wide? Well, if that's the case, it's kind of too bad. It'll go ahead and pad it out to more than 8 characters. It does not truncate it. the formatting will pad it out to 8 characters, but if the data is more than 8 characters wide, then that's what happens. It does not truncate the 8 characters. So integer data types hold whole numbers, either signed or unsigned. And like I said, I would not worry about using signed versus unsigned unless I had a real reason. I'm not going to say to myself, well, somebody's age is never going to be negative, so I'm just going to use an unsigned value. You know, you would use an unsigned value if you want the extra magnitude of data, if you want to be able to hold numbers of up to 4 billion rather than 2 billion. Or there may be other reasons, but not just as a general matter. Of course, you don't need to make them all unsigned if you're sure that it's going to go negative. I guess there's no problem doing that. And then floating point data types, when you're declaring a literal, you can put an F after it to specify that it's a float, or a D after it to specify that it's a double. So if I go to my code and I declare a float, float F is equal to 107. Now I hit Control S to save. It's going to actually give, no, it's not going to give me an error. In some languages, well, I did not make it a floating point value. Okay, and there's the syntax error that I was expecting. And that looks odd. Well, 107.0 is a floating point number. Why wouldn't it store it in an F? Because the default integer data type, like if I did I is equal to j is equal to k is equal to 1, like that, the default type for an integer is int. And so they're all going to fit comfortably in this int data type. However, the default data type for a literal that you type in, a floating point literal, is double. And the compiler is not willing to let you try to assign a double into a float. But you can say, well, yeah, this number is really a floating point. I mean, it's a float. Format it to fit into a float. The other way you can get around this is just to declare all your floating point numbers as double. And that's probably what I would actually do. You get extra precision. It's not going to really slow the program down. We're not memory constrained for the, so what I would have done is I could have declared that as a double, and then I would not have had to suffix my literal with an F. But if I wanted to specify that this was a double, if I had any doubts, I could put a D after it. So if you see a suffix of an F, it means the compiler is going to format that data to fit within a float, and if you see a D, it's going to format it to fit within a double. It does not matter, really, if you're going to store something into a double, whether you put an F or a D after it. Because if you leave off the D, it defaults to being a D anyways. And in scientific notation, oh, I skipped this one, the decimal type, M. Put an M after it to make it a decimal. Why are they using M? Because you can use the decimal type to store money values. And then include an E for an exponent. If this floating point number here, I could have done 107.0 exponent, I didn't. Let me type it. Exponent. Oh, come on. E31, like that. Speed of light, maybe 3.0, exponent 8 meters per second, if I'm remembering that correctly. So C# displays floating point values in the most concise way. So if you use string.format, then if the number will fit comfortably in a few digits without using an exponent, then great, it'll display it, just as a few numbers without an exponent. However, if displaying it with an exponent is a shorter way of doing so, then it'll do that instead. What do I mean by that? Well, what if we had this number, 107, like that? Well, it's easier. I need to declare this as a double because this is, actually, I'm not sure why I'm getting that error. That fixed it. Oh, because it was treating it as an integer, since I did not have a decimal point in it. And that was too long to fit into an integer. Okay, so anyways, this is a double. It's got a whole bunch of decimal places. This is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. That's the same. as 1.07 e to the 20. So if I printed it out without specifying in the format specifiers what it is, it's not going to print that. Instead, it's going to print that, just because that's a shorter representation of it. So format specifiers let you control. Hey, Denise. Let you control how it's going to be displayed. So you can specify that something is going to be currency. If it's going to be currency, it will put a $ in front of it, and it'll display 2 decimal points after it. So let's pretend that one of our numbers here is actually supposed to be displayed as currency. So down here in our string.format, where it says this number is that, we're going to specify that it's supposed to be displayed as currency. The fashion that we're going to do that, oh, and it's not going to display an example of the code. I did not want to fumble around. I thought that I'd get it right. Did we have an example further up here? Nope. Google that up. We have some examples. Well, when we use toString, we can do that. How about .format? There we go. After the number, you specify a colon, and then you specify the data type. So after my 0 colon in my format string, I'm going to put 0 colon C for currency. I believe that to be what the PowerPoint said. And it should format it like it was a money value. So here, the number is curly brace 0 colon C. And when we run it, makes it look like money. $2.00. That's kind of nice. That's something that I do not believe Java has. Alrighty. Out of all these data types, there's decimal, there's E, scientific. You can force it to print exponential. G for general, variable, which is what it does by default, either with decimal places or scientific. N, just for number, but it puts commas in them. That's interesting. I feel like testing that out. I'm going to go back to my code. I'm going to make I a large number. I is equal to 1, 2, 3, 4, 5, 6, 7, like that. And then when I print it out, I'm going to print it out as a number with an N. So 0 colon N. Run that. And it padded out with commas, like we like to see. Can we do both currency and commas? I don't know. Will it put commas there automatically when I change it back to a C? Yep. Nice. So the currency format pads it out with the commas. Make it look nice. Alrighty, I want to scroll down to where we're getting some input. Maybe that's short-sighted. But getting input is so cool that accepting console input. We would have to go back or create a new console app in order to test this out. But here we're going to write. Interesting that we're not using. Using system means that we do not have to type system.write or system.writeLine. The word using tells it that we can just type the name of the method and then we'll assume that it is system dot. I tend to type it out anyways. So system dot write into the price of the value, and then read the line. We read it in as a string, and then we have to convert it. So we use convert to double to turn that string into an int. And then we write it out using format specifiers. This is important enough, this convert.toDouble, that I'd like to stick it into our code anyways. So I'm going to go back to our code. Did we have a string? Yes, we did. So I'm going to store a value in our string. S is equal to 123.45. And then I'm going to convert that to store it in our floating point value, which I believe I've called F. F is equal to convert.toDouble. And then I need to pass the data that is being converted as a parameter to that method. All right, so convert.toDouble S takes this string, does the magic required, and turns it into an F, into a floating point type, a double. If you type convert dot, you'll see that there are all sorts of data types that it'll do a conversion to. Convert dot to byte, to character, to date time, to decimal, to int 16, 32, 64, to assigned byte, to single. What's that? To string, to unsigned ints of 16, 32, and 64. Curious about that single. Why am I showing you this? Because whether you're writing a console application or writing a GUI application, your input's going to come to you in the form of strings. Now, if you were a Java programmer, you're used to the idea that you can call .nextInt, right? And it'll do the conversion to an int for you. This will not do the conversion to an int for you. Instead, you're going to get a string, and you have to convert it to the correct data type. And absolutely, that's going to happen when you're reading it from a form, WPF. All right, one more thing I want to show you about strings before I show you the homework, which is say that you need to put in a very long string. Like I want to do this. S is equal to, I love C#. It is by far my, and then I'm going to embed a carriage return. \n. Favorite language by far, period. \n. I have never loved a language, \n, as much as this. \n. Okay, so I have a very long string separated by \n's. It's all in one literal. I'm going to comment out this string formatting so that I can see what it looks like when I call messageblox.show. And there it is. I love C#. It is by far my favorite language. I guess I have by far twice. It's redundant. So anyways, the /n's broke our output up. If we did not have those /n's, then we'd have a very wide message box. Like if I went and I removed that \n and the next one and the next one. We'd have a very wide message box. It'd look kind of dumb. So I'm going to leave that as is. Changes are not allowed while the code is running. Thank you for being that way. And I mean it sincerely, not sarcastically. Okay, so I close the app. Here's something else you could do, though. You don't have to type it all in one line. You could do it like this. S is, I love C#, period. It is by far my, \n, in quotes, semicolon. And then S plus equals. And then some more text. Programming language, \n, end quote, semicolon. What this means is append this text to that string. And that way I could add a whole bunch of, stuff together to store into the string without creating one line of code that went on forever and ever like that. I'm showing you this because the code is the program. Oh, well, I guess I should have shown you this before homework assignment 0B, because homework assignment 0B, if you haven't done 0B yet, then you may want to take advantage of it. It doesn't matter whether you separate them by backslash ins or not. I may need to revise the instructions for that. Hopefully you know what a backslash n does by now, though. So anyways, that's one way to do it. Or you could do this. C is equal to I love backslash n, end quote, plus, and then hit enter. C# programming, backslash n, end quote. It is so cool, exclamation point, backslash n. Right, so you have several ways. Whoops, I've made a mistake. Nope. After I thought about it, it decided it was not a mistake. You have several ways. One is to create a great big string like that. Another is to kind of break it up and append text to it each time. The third way is to just separate the components of it with the plus sign, like that. So why am I mentioning all that? Because here's your homework. And by the way, messagebox.show also works within console apps. It will still pop up the window that you want to see. Now we'll demonstrate that really quickly. File, new project, console app, whatever. All right, I'll zoom way in. Inside of main, messagebox.show. Hi there. Put quotes around that. Now when I run it, ooh, it doesn't know what a message box is. Now according to our instructions, we were supposed to be able to use a message box in lecture B. In order to call message box from inside a console app, we're going to have to add one more using system.windows.forms. So go back to my code. Here's my console app using system.windows.forms. That looks odd. What have I done wrong? Left. Oh, for Pete's sake. Alright, hopefully I know now. What we need to do is go to the Solution Explorer, click on References. We want to add a new reference. So add reference. What we want is, which one do we want? Yeah, we already missed it. System.windows.forms under .NET. I'm not seeing .NET there. I could do a search. There it is. I did a search for forms. I'm going to do add a reference to system.windows.forms. Click OK. And that corrects my using error message. System.windows.forms. I better update the instructions to indicate that that's what you do. Put a screenshot into it. Okay, now that's the case. Yes, I can prefix the message box call with the entire path, but I don't need to because we have the using statement up there. And when I run it, hi there. All right, so that worked. So what is the homework? The homework is to display, remember the last one where we were displaying poetry in a console app? Same thing here, except we're going to display it in a WPF app using messagebox.show and in a console app using messagebox.show. So what are you going to have to do? I think I would store it in a string first, but it's not strictly required. You could just do messagebox.show parentheses and then put your entire poem right in there. And so first part is to do it in a WPF. The second part is to do it in a console app. To get the console app to work, you're going to have to add a reference to system.windows.forms. All right, I hope that makes sense. Please call, text, or email if you have any questions. I will update the instructions to make that a little bit easier.